Use the graph of r of x to complete the following. So I want you to take a minute here and find these 6 limits. Remember that if our limit does not have a positive or a negative exponent, that it's our job to look at it as it's coming from the left and the right side. Okay, so take a minute and find these 6 limits. Okay, so you should have gotten these 6 answers as your limit. Let's just check one of them. So let's look at this one. So if we're looking at as x approaches 4, so here's 4 right here, right? Remember, we want to draw a line at 4. So as x is approaching 4 from the right, looks like it's going toward positive infinity. And as x is approaching 4 from the left, f of x is approaching negative infinity. And when our right hand and our left hand limit are not the same, our limit does not exist. Okay, so let's take a look at our next one. I'm going to erase some of this. It says write an equation for our x. So I'm going to scroll up here, and I'm actually going to do it up here so that we can see our graph. So remember that our x-intercept is in our numerator, our vertical asymptotes are in our denominator, and to find our horizontal asymptote, it is based on our exponents in our leading coefficient. So let's take a look at this. Let's find our x-intercepts first. So it looks like we've got one right here. So that's -8, so that's x plus 8. And it looks like we've got another one here at 2.5, so x minus 2.5. And vertical asymptotes, let's see. So we've got vertical asymptotes, looks like right about here at -2, which means we have x plus 2. And it looks like we've got another one right about here at x equals 4. So x minus 4. Okay, now we need to find our horizontal asymptote. So we can see here that there's a little imaginary 1 there. So if we were to add those together, you have an x squared over an x squared. And remember that when our n is equal to our k, our horizontal asymptote is the ratio of the coefficients. So let's find what our horizontal asymptote is. And it looks like it's at about here at y equals 2. So if our horizontal asymptote is 2 and it has to be an a over b, that would mean it's 2 over 1. So it's 2 over 1. And you can erase that 1, of course. So our final equation is going to be 2 times x plus 8 times x minus 2.5 over x plus 2 times x minus 4. Write an equation in factored form for a rational function with a vertical asymptote at x equals 4, a horizontal asymptote at y equals 5, and an x-intercept at -8, 0. What is its y-intercept? Okay, so the first thing that we can do is we can try and figure this out, right? So we see that it has a vertical asymptote at x equals 0. And remember that our vertical asymptote is our denominator, which tells us that our denominator is going to be x minus 4. And then it says we have a horizontal asymptote at y equals 5, which means that, so whenever we have, so let's look at our rules. When we have n equals k, our horizontal asymptote is a over b. When n is less than k, our horizontal asymptote is y equals 0. And when n is greater than k, our horizontal asymptote does not exist. We don't have a horizontal asymptote. Oops. So we have no horizontal asymptote. So the only way that we could get x equals 5 is if we have this scenario here, right? Which means that our ratio is going to have to be 5 over 1. And we have an x-intercept at -8, which means we have an x plus 8 up on top, which makes sense, right? This is a 1, this is a 1, so that's like saying 5x over 1x, right? Our horizontal asymptote is still 5 because of that ratio. Our n and our k are equal to each other. Okay, so we've got this as our equation, so now it wants us to find our y-intercept. In order to find a y-intercept, we have to plug 0 in for x. So if we do 5 times 0 plus 8 over 0 minus 4, we get 5 times 8 is 40 over -4, which is -10, which means our y-intercept is 0, comma, -10. So here's our equation, and here's our y-intercept. Now this one says, write a rational function in factored form such that the limit as x approaches infinity, r of x approaches 2, and the limit as x approaches -4 from the right, r of x approaches infinity, and the limit as x approaches -4 from the left, r of x approaches -infinity, which we know tells us that the limit at x as x approaches -4 does not, f of x does not exist, right? Because these are not the same. And we also have the limit as x approaches -5, r of x approaches 0. And r at -5 is 0, which tells us, this tells us we have a closed circle. Okay, so let's graph this out so we know what it looks like, because I'm not even sure what it looks like. So let's take a look at this. So we've got the limit as x is approaching infinity, f of x approaches 2, which kind of tells me that there should be a horizontal asymptote here. And the limit as x approaches -4 from the left, from the right, sorry. So let's look at -4, 3, 4. This is -4. So as it's coming from the right, it approaches infinity. So kind of looks like our graph is going to look something like this, right? And then our limit as x approaches -4 from the left, it approaches -infinity, which means as it's coming from the left, it's going down, which we already said our limit does not exist there, which tells us there's probably a vertical asymptote there. And then the limit as x approaches -5, so here's -5, r of x approaches 0. Okay, so let's redraw this graph. So as it's approaching -5 from the right, it's approaching 0. So we know that this is coming like this. So as it's coming from the right, it approaches 0. And as it's approaching from the left, it has to also approach 0 because our limit at that value is 0. And then r of -5 is 0. So this is what our graph would look like. So based on this, we know that we have an x-intercept here at -5. So we have an x plus 5 on top. And vertical asymptotes. We have a vertical asymptote at -4, which tells us that we have an x plus 4 on the bottom. So again, these coefficients are the same, which tells us that we're going to have a ratio for our horizontal asymptote, which we found to be y equals 2, which means our ratio needs to be 2, 1, which tells us that our equation is going to be 2 times x plus 5 over x plus 4.